So this is a new rule for calculating limits. It's called L'Hopital's rule. Now, this is a person's name. L'Hopital was a French person a couple hundred years ago. He commissioned this research that went into developing this part of calculus. So he gets his name on it, like a sports sponsorship. Now, again, we are trying to calculate the limit of some quotient of functions. They're both continuous, but direct substitution is not working out for us because both of those functions are 0 at our target coordinate. So what we can do, as long as f and g are both differentiable, and as long as g prime of x is not 0 close to a, then we can try taking the limit of their derivatives instead. So here, notice that I am not using the quotient rule for derivatives. I am replacing the function f by its derivative. And I am also replacing the function g by its derivative. So the new numerator is f prime of x. The new denominator is g prime of x. And if this new limit exists, then the old limit has to be equal to the new limit. So this is the technical version of what I was saying before about approximating the function by its tangent line. So the technical thing that we're doing here is we are evaluating this limit by taking the derivatives of both of the functions and evaluating that limit instead. And so if the new limit is, positive infinity, the original limit is also going to be positive infinity. If the new limit is negative infinity, the original limit is going to be negative infinity. And if this new limit still has my problem, my 0 over 0 situation, then I just have to take a derivative a second time. And eventually, I might get to something I can actually compute. So let's take a look at this problem again. My limit is the limit as x goes to 1/2, the cosine of pi of x, all on 1/2 minus x. So L'Hopital's rule suggests to me I can try computing this by replacing these functions with their derivatives instead. Now, I am only allowed to do this because of the 0 over 0 situation. This is a special rule just for that issue. So I'm going to do that. The derivative of my numerator is negative pi sine of pi x, like we saw on my previous clip. The derivative of the denominator is -1. And this one I can do with direct substitution. My x's are just in the numerator. My denominator is a constant. And so direct substitution tells me that the answer is going to be pi. This limit here is equal to pi. So the limit I started with is also equal to pi.